My presentation will have an introduction. We are going to talk about emerging pollutants and environment. Lately, we were going to talk about the core of this presentation, the emerging pollutants in Spain, in Spanish urban wastewater and their removal. And we are going to talk about two different case studies. One of them is a study of 2 years in 4 different wastewater treatment plants around in different geographical areas of Spain. And the other is another study in the same time, 2 years in 3 different wastewater treatment plants in Catalonia. And lately, we are going to talk about the wastewater treatment processes necessary, well, that could be useful for eliminate emerging pollutants. Emerging pollutants, as we know at this moment, is a short history. The first published report was in 1999. It was in a workshop in the US National Research Council. And the first publication, it was in a journal. It was in 2001, Dalton. And well, the journal was the Journal of the American Society Mass Spectrometry. When we are talking about emerging pollutants, we are talking about chemicals. And well, some figures that appears here, somebody have talking about this. More than 71 million substance has been assigned in the register, registered numbers in gas. There are more than 50 million available, commercially available. Around 300,000 are inventoried or regulated worldwide, and every day 12,000 new substances are added each day. But when we are talking about emerging pollutants, most of them are pharmaceuticals. Over 21,000 formulated drugs products, over 3,200 experimental drugs. Well, we are talking about a very big numbers, very huge numbers. Somebody says also that it's very difficult to have data about, for example, drugs, about pharmaceuticals. For example, here we have some data. They are not very updated, but this is one of the things that we can have. And for example, the British government published one report talking about 14 different types of drugs, and in another 40 countries. And what they conclude is that, for example, the United States is the country where they consume more drugs, but the second in consumption is Spain. What are the two major sources for new pollutants in the environment? Well, most of them are new chemicals, new drugs, pesticides, and lately I think that we have to talk also about nanomaterials and some byproducts of new processes. But we can talk about emerging pollutants or emerging pollutants, previous and recognized pollutants, for example, new advances in chemical analysis because they were not previously identified. Now, for example, we can detect lower concentrations, and that made possible to try to find new emerging pollutants. There are other ways to get this kind of pollutants. For example, here appears several examples. One of them is all pollutants in new places, or all chemicals as new suspects. For example, monopoly and heteropoly tungstenates. Several. We have here a list of other examples about emerging pollutants. As we have said, most of the emerging pollutants that we are measuring are pharmaceuticals, are the main contributors. And within pharmaceuticals, we can classify them into different types, but here are the more commons. But we have to take also to take into account the personal care products, for example, fragrances, sunscreen agents, insect repellents, or antiseptics. But there are also other important substances, for example, surfactants and metabolites, flame retardants, industrial additives and agents, and gasoline additives. What are the roads for PPCP entry on the environment? These are the most, in my opinion, the most important emerging pollutants. There are three main roads. One of them is sewerage, for example, after excretion, bathing, for example, topical drugs or residues, and disposal to drains. The other is another important source of PPCPs in the environment, trash, discarding unwanted PPCPs. The used delivery device or containers with residuals or non-human use, for example, in agriculture, aquaculture, and feeding, different types of feeding of animals. The efficiency of the removal of PPCPs is in wastewater treatment plants is highly variable. The concentration in the treated sewage often runs in a very wide range, from 1 to 100 nanograms per liter. But removal does not necessarily equate with destruction or with elimination of toxicity. Why? Because, for example, we can find biosolids in the solid sludge. We can find these pollutants in solid sludge. There could be transformation products and new products of this kind, and we can find also metabolites from them. Some headlines about the potential of human health. The human exposure to these pollutants is, in my opinion, limited. The concentration is very low. Many PPCPs in source waters are removed from treatment when we try to finish to produce drinking water. Toxicological studies are restricted to in vitro studies and are very limited epidemiological data in these concentrations. With the implementation of the wastewater directive in 91, Spain have constructed around 3,000 treatment plants all over Spain, and that means that we are now treating around 90% of our urban waters. But of this treatment, we have only 10% of this treatment with a tertiary treatment. These are the plants that have tertiary treatments. And also there is a clear, the public is worried about this, and there are pieces of news talking about this. For example, this is an example of a piece of news talking about 88 pollutants in rivers in the region of Madrid. Let's go to the first example. Well, this study comes from one very big project related to reuse. Spain is a semi-arid country with big problems with water, and the analysis was done in 5 different wastewater treatment plants in different parts of Spain. In the south, in the center, two plants, in the north, and in the east in Catalonia. We studied 100 different compounds, but we found that only 20 compounds are responsible of the load of pollutants in these compounds. These 20 compounds are different types of pharmaceuticals, but they are also metabolites. There are a very big amount of metabolites in these spots. Talking about differences among plants, we can see here big difference or important differences among plants. For example, the load of or the total concentration, the load of pollutants in Almería, in the south of Spain, is higher than in other places. That may be because of the concentration of wastewater, but maybe also because the plant is near a big hospital, and perhaps this is one of the reasons. The other, well, there are differences, but the other in Madrid, the number 4, it's a plant that treats urban and industrial wastewater. We can find differences, very big differences, between in different seasons. For example, winter, spring, summer, in different places. And as you can see, the sequence of the figures is similar in both when we are talking about seasons, or we are talking about months. And for us, it was a surprise that during the months of the summer months, the amount of antibiotics in these plants are higher than, for example, in winter months. The elimination of different compounds it's more related to the type of molecule than to the type of pharmaceutical product. For example, we can find we can eliminate or find the elimination of stimulant compounds in more than an 80%, or UV filters in more than an 86%. But for example, there are another that is difficult, or the elimination is very poor, reaching removal efficiencies of less than 25%. The second case is 3 plants in Catalonia. As we can see also, the load of different plants is very different. We are talking about, and even the distribution of compounds it's also different. And here we can find the influence, or excuse me, the sewage sludge, the amount of this different type of compounds in the sewage sludge. Here we have the distribution for 23 different compounds. We are talking about removing, sorbing, and discharging. And if we compare this data with data from the literature, for example, from a study in France with this study was taken during 4 years, I think, and there were a lot of analysis, and they, as a summary, they give this data about removal rate, and there are differences, there are big differences with the data that we found in our studies. It's difficult to know how to improve the efficiency in removal during the secondary treatment, during the biological treatment. We try to relate the removal efficiency with the distribution between between octanol and water, and in some cases we can find a good relationship, but in many other it's difficult to find some kind of correlation. The World Health Organization have published this data about different processes and how they can remove the range of removal of different types of treatments. Most of them are related with advanced oxidation. Well, as conclusions, you have there the conclusions. Perhaps the main conclusion is that there are no conclusions. It's very difficult to find some correlation between different types of treatment, different streams and things like that. I think that we need to know more about how the PCPs are consumed, the amounts that are consumed, and to have more data about this. Thank you very much.